So in this lesson, we look at equations of normals to a curve. Equations of normals to a curve. And the first thing that I want to explain is what we mean by the term normal, so that we can be able now to find the equation of the normals to a curve. If you consider this curve here, let's say that's the curve, and we have our point here, and we want to know what we mean by normal at a certain point. If we have our tangent, the point that is touching that point, this is our tangent. This is the tangent. At that point, we can call this point A. At point A, when we talk of a normal is a line passing through the given point and perpendicular to the tangent at that point. So when we talk of a normal, again, is a line passing through the given point, passing through the given point, and at right angle or perpendicular and at right angle to the tangent. It is at right angle to the tangent. So if this is our tangent and we come and measure here, we have 90 degrees to the tangent, we have 90 degrees, then we'll say that this is the normal. So a normal is a line passing through the given point. This is the given point and at right angle to the tangent. So in our lesson today, we want to know how do we find the equation of the normal to a curve. When we have been given the curve and we are told to find the equation of the normal. Just before we do examples, I'd like to remind you what you covered in the equations of a straight line. When we have a straight line here and we have another line which is perpendicular to the first one at the point, at this point, let me use the ruler so that I can explain something before we do the examples on how to find the equations of the normals to a curve. So when we have that, so we can say that this line, here we have two lines. We can call this line 1 and we have line 2. These two lines, line 1 and line 2, are perpendicular to each other. So they form an angle of 90 degrees. So if we have the gradient of line 1 as M1 and we have the gradient of line 2 as M2, we realize that in the equations of a straight line, the product of the gradient, should be equal to -1. That is for perpendicular lines. So the M1, when we have M1, we multiply by M2, it should be equal to -1. So we need to know that before we do the examples, because in our case here, we have line 1, which is the tangent, we have the normal perpendicular to the tangent, and therefore we should note that the gradient of the normal times the gradient of the tangent should be equal to -1 because they are perpendicular. So if you have the gradient of line 1 maybe to be a half, and you want to get the gradient of M2, you just need to come and say M1 times M2 is -1. And therefore, if M1 is a half, and you don't know the M2, multiply by M2 is equal to -1. Therefore, it means that M2 will be equal to -1 divided by a half. So we are going to have -1 times 2/1. that is negative 2. So the gradient of M2 when M1 is negative a half, for M2 is 2. And for sure, when you multiply negative a half times 2, you'll get that the product M1 by M2 is equal to negative 1. So I'd like us to do examples on how to calculate or how to get the equations of normals to a curve. And we have seen that a normal is a straight line, is also a straight line passing through the given point at right angle to the tangent. So we can do these examples. We are going to do several examples here. So the first one, we are told find the equation. The question is find the equation of the normal. In this case, now we have the normal. Find the equation of the normal to the curve. To the curve, we've been given the curve which is y is equal to x cubed minus 2x minus 1 at the point 1, negative 2. Find the equation of the normal. Find the equation of the normal to the curve y is equal to x cubed minus 2x minus 1 at 1, negative 2. So in this again, we'll start by following the procedure that we are following when getting the equation for a tangent. So the first thing, because we want now to get the equation of the normal, and we have the curve. So the first thing, we need to get the gradient. So first we start with the gradient function. We get the gradient function. So that is dy dx. So the gradient function, so we need to differentiate. So we have 3 times the constant of x, which is 1. So we have 3x, 3 minus 1. Then minus, here we have 1. 1 times 2, we have 2. X raised to power 1 minus 1, then minus 0, because the derivative of a constant is 0. So we have this as 3x squared minus 1 minus 1 is 0. 1 minus 1 is 0, and therefore a number raised to power 0 is 1, so we have minus 2. So that is the gradient function. Then after getting the gradient function, we need now to get the gradient. We need now to get the gradient at the point 1, negative 2. So here we have the x and the y. So we need to get the gradient at that point. So where we have x, we substitute with 1. So our gradient, which is dy dx, will be equal to 3 multiplied by x squared. Our x is 1, then minus 2. So we have 1, 3 minus 2, we have 1. So our gradient is therefore equal to 1. That is now the gradient at that point, and that is the gradient of the tangent. So if we hand the curve, if we have our curve in this manner, let's say we have our curve this way, and we have now this as our point, and we have the tangent here. We have the gradient of this tangent. The gradient is equal to 1. So we also want now, because we want to get the equation of the normal, we also need to get the gradient of the normal. Our point is this. So we also need to get the gradient of the normal. So if we have our normal here, this is the normal, making an angle of 90 here. We also need to get the gradient. We have the gradient of the tangent. We require now the gradient. We can call it M1. We require the gradient of the normal. And the point that we have here, the point is 1, negative 2. So we find first the gradient of the normal. And we know very well the gradient of the tangent multiplied by, which is m, multiplied by the gradient of the normal, which is m1, should be equal to negative 1. And therefore, the gradient of the tangent is 1. multiplied by the gradient of the normal should be -1. So for us to get the gradient of the normal, we divide this by 1 by 1. And therefore, our m1 should be equal to -1. And therefore, the gradient of the normal, which we have said is m1, is equal to -1. So now we have the gradient of the normal, we have the point, and we can get another point which is an imaginary point x, y. So we find now the gradient of the normal at this point 1, -2, and we have the gradient of the normal as -1. So we simply come and write the gradient for the normal is -1. Then the point we have 1, -2, and the imaginary point x, y. So with this now we can find the equation of the normal to a curve. And therefore we have our gradient we know is given by change in y all over change in x. Our gradient is -1 and whole number always over 1. Change in y we have y minus -2, y minus -2 all over x minus 1, x minus 1. So this is -1 over 1 is equal to negative times negative, we have positive, so y plus 2 all over x minus 1. So we can close multiply, we have 1 into bracket y plus 2 multiplied by is equal to -1 multiplied by x minus 1. Then we open the bracket, so we have y plus 2 is equal to x times -1, negative x, -1 times -1, we have positive 1. And therefore, we have that y will therefore be equal to -x plus 1. We take 2 to the other side, we have -2. So our y will be -x, 1 minus 2, which is -1. And this is the equation of the normal. This is the equation of the normal. And as we have seen, the normal is a straight line. And therefore, we also expect the answer to be an equation of a straight line, which is of the general form y is equal to mx plus c. And we can see clearly that our gradient is -1. And our gradient here is -1. So this is the equation of the normal. So I repeat, how do we find the equation of a normal given the curve? The first thing, we get the gradient function. Now, when we are getting the gradient function, we want to get the gradient of the tangent. We want to get the gradient of this tangent, and the gradient, therefore, when we get the gradient function, we have been given the points, so we can substitute x with 1, so we get the gradient as 1. That is the gradient of the tangent. So if we had been asked to find the equation of the tangent, we'll come and use this gradient. But now we are told to find the equation of the normal. So we also need to get the gradient of the normal. And we know very well that the gradient of the tangent times the gradient of the normal is equal to -1 because they are perpendicular lines. They are perpendicular. They are perpendicular lines. And therefore, the gradient of the normal is -1. So we have the gradient of the normal, we have the point where it is passing through, and we have an imaginary point xy. We use it now to find the equation of the normal. We can do another example. Example 2. We are still in finding the equations of normals to a curve. Finding the equations of normals to a curve. So we are given, in this case, we are given the following. We are told number 2. What is the equation? What is the equation of the normal? What is the equation of the normal to the curve? What is the equation of the normal to the curve y is equal to x squared minus 1 at the point 2, 3. At the point 2, 3. That's the question. What is the equation of the normal to the curve y is equal to x squared minus 1 at the point 2, 3?